we can go ahead and get started, which is awesome. So this is your actual start. Well, I mean, last lesson was your start to trigonometry, but that was just angles. Now we actually get to see what trig is. So right triangle trigonometry, we're going to define trig functions of acute angles, and then we'll explore outside of that in a different lesson. We're going to evaluate them as well, and then we're going to jump into trig functions for special angles. Okay? Now, as a quick review, let's go through degrees and radians real quick. So this is 0 degrees. If I rotate it this direction, it's 90. What is that as a radian measure? Do you remember? I heard a lot of pi's. Pi over 2. That's it, pi over 2. Okay. All right, next. Now we're going to rotate a full 180.
That's pi.
And that's pi. Yep. Then we're going to rotate down to here, which is 270. 3 pi over 2, right? And then a full 360 is 2 pi. Okay? So again, what I would probably do is start memorizing some of this stuff. I mean, you could convert it by hand and stuff, but you know, tattoo that to your brain. Those are very important. Okay? Alrighty. I'm excited. This is gonna be good. Okay, a little intro. So let's consider a right triangle with an acute angle that we'll call theta. And here it is. I'm going to draw it off to the side. Okay. Now here's what I'm going to do. We talked about radian measure, we talked about degree measure. I'm going to represent that angle as a ratio of 2 side lengths. Okay? So this angle is creating those 2 side lengths as a ratio here. So let's put here the sides relative to the position of theta can be labeled as opposite, adjacent, that means next to it, and hypotenuse. Okay? We'll use a different color here. So there's my angle. Okay, first, opposite. Okay, what side would be opposite of that angle? It's going to be across from it. So we're going to call this the opposite side. Okay? With respect to theta. Adjacent means next to it. Okay, so what's next to this angle? Right here. That's going to be our adjacent side. And then we know what the hypotenuse is. That's the largest side. It's across the 90. So there, I don't know how space, let me bring it up, is the hypotenuse. Okay? And again, this is all in relation to the angle. If I flip the angle to this location, then this becomes my adjacent side, right? And this will be my opposite side. So it all depends on what angle we're looking at. In this case, we're just looking at that angle. Okay? All right. Now, again, I'm going to define that angle as a ratio of 2 sides. So there's a lot I could choose from, right? I could pick these 2 sides to represent the angle. I could pick these 2 sides. I could pick these 2 sides, right? A lot of ratios. So we need names for those ratios. That way we know what 2 sides we're looking at. So we're going to come up with some names here. All right, so we can define theta as a ratio of the side lengths of the triangle. And again, since we have a lot of ratios, we got to give them some names. And these are the names we're going to use. We're going to use the words sine. In parentheses, I'm going to show you how we abbreviate it. So sine is abbreviated as SIN. We just knocked the E off. Okay, we're going to do cosine as another ratio name, which we're going to just abbreviate as COS. Okay, another name we're going to use is tangent. So TAN. And we're not done. We have 3 more names that we can use. And this is the kind of weird part, because people are like, well, isn't there just 3 ratios? You know, you can do these 2, you can do these 2, and these 2. Well, can we just flip the ratios as well? Flip the way we do it? That's another 3 that we have. So we have to have more names for it. So let's see, we can use the words cosecant, which we abbreviate as CSC. We can do secant as SEC. And our last one, cotangent, COT. Now, here's the deal. Could you say sin, cos, tan, cot, sec? I don't know how you're going to say that one. Here's the deal with this, okay? And professors pronounce it with abbreviations. Some do, some don't. You know, do you say sin or do you say sine when you see it? It doesn't matter. My reasoning is this. If I see this, I'm still going to say sine. If I see this, I'm still going to say cosine. Okay? Why is that? Because in the English language, what's that mean?
Etc.
Yeah, but do you, when you see it, do you say, oh, it's ect? You don't. So, I don't know. Again, I'm not going to criticize. If you say cos, tan stuff, go ahead. You know, like I said, professors do it all the time. To me, I kind of just like saying the whole word anyway. Okay? All right. So far, this is what we did. We made a right triangle. That's my angle. And I'm representing that angle as a ratio of 2 sides. Okay? And again, there's so many different sides, or so many different ratios, that I got to have names for it. That way I can know what 2 sides I'm looking at in what order. Okay? So I'm going to leave that right there. And next to it, we're going to put an example with those ratio names with it. So here we go. Okay, example. So here's my triangle. And I decided to make it easy. So we're going to do a 3, 4, 5 triangle. Okay? Those are nice triangles to have, 3, 4, 5. And we'll measure them in feet. Okay? Just like that. Okay? Now, here we go. So, sine. So let's go ahead and figure out what 2 side lengths go with the name sine. Okay? So sine of theta is going to equal, and actually I apologize, I forgot to label the sides, huh? So this would be my opposite side, so I'll put O for opposite. This is my adjacent side, and this is my hypotenuse. Sorry about that. So sine is defined as these 2 sides. It's your opposite over your hypotenuse. Okay? So we call that sine. And for this triangle, that's going to be the 4 and the 5. Okay, so those 2 side lengths represents that angle there. Okay, next, cosine. It's your adjacent over your hypotenuse. Okay, so those 2 side lengths as a ratio we call cosine. So in this triangle, that's going to be 3 over 5. Okay. Tangent. Is your opposite over your adjacent side. So notice tangent does not use the hypotenuse. Okay. So in this example, that's going to be 4 over 3. Now that should look familiar from geometry just a little bit, okay, if you recall. Any questions so far? Now, there is a fancy way, not fancy, but a cool way of remembering this, and this might sound familiar. SOHCAHTOA. Okay. That's a cool little technique to figure out what name goes with what 2 sides. So the first letter of each part is the actual trig name. So this will be sine, this will be cosine, and this will be tangent. The other 2 letters tells you what 2 sides go with it. So sine goes with your opposite and hypotenuse. Cosine goes with your adjacent with your hypotenuse. And then TOA, tangent, goes with opposite and adjacent. It works. When I was tutoring my stepdad, he had to go back to college. He had to take a trig class. And to this day, he still remembers SOHCAHTOA. He doesn't remember too much from the trig he was being taught, but he still remembers SOHCAHTOA, which is pretty cool. Now, unfortunately, there's not a cool name or cool little mechanic to memorize the other names, but you'll see that once I get the other ones written down and we go through some examples, you'll see different ways of remembering them. So, now I'm going to take each one of these, and I could flip them, right? I could flip the order of them, which will create our other three trig functions. So let's start with cosecant. So cosecant is the hypotenuse over the opposite side. So see how it's like the reciprocal of sine, right? You see how they just flipped it? So, oops, wrong color. For this example, okay, that's going to be 5 over 4. So already we can see that there's some sort of relationship between these two, right? It's just the same numbers flipped. Alrighty, next we got secant. SEC, okay? And that's going to be your hypotenuse over your adjacent side. Now you can, if you go back to the other three, that looks like cosine, right? They just flip the two sides there. So secant of theta, for this guy would be 5 over 3. So if you look at the pattern, if we're just flipping these, I think cotangent has to be this flipped, right? So let's do that next. Cotangent is going to be your adjacent side over your opposite side. So it's just flipping those two. So for this example, that's going to be 3 over 4. And there they are. That's our 6 trig functions, okay? And we're just, again, we're representing this angle as a ratio of two sides. Now we'll go into y and different things like that. We got a couple lessons that'll help unfold that a little bit more. But for right now, we just have to know what those names are and what sides go with it. Okay. Any questions? Now here's the cool part. This is only being defined with this guy, an acute angle, right? Has to be an acute angle. So I'm not going to define it off of the 90 because what's going to be adjacent, right? You have two choices there. So we're not going to ever use the 90 when defining those. Now, can we do 90 degrees and stuff? Yeah, we'll get to all that. But for right now, we're dealing with just a triangle. Now, these ratios always work for any triangle that's similar to this. Okay? So let's write this down. And why not? We'll write it how I wrote it in my notes. What's cool about these functions?
What the heck?
Is that any similar triangle, there we go, lost my place, with a common angle theta, they're corresponding. Did I say it? Oh, that's right. I'm just so excited I had to say it twice.
On purpose that I wrote it to be funny.
That's okay. I didn't even realize I did that. Corresponding sides are proportional, and the value of each trig function of theta will be the same. Oh, we're going to keep it up there now. Let's look at that 3, 4, 5 triangle again. Okay, so there's my 3, 4, 5 triangle. Now what this is telling me is this. If I were to create a similar triangle, so let's multiply that all by a scale factor. So let's do a scale factor of 2. Okay? So this will be a 6, this will be an 8, this will be a 10. Now, if you remember from your geometry classes, they're similar by SSS, right? Side, side, side. So if I took, let's say, sine of theta on this side, which is your opposite over hypotenuse, so 4/5. And on this side, I'll do sine of theta, which is opposite over your hypotenuse. That reduces to 4/5, which, hey, aren't they the same? Right? So that's one of the things that mathematicians are picking up on. They're like, hey, wait a minute. It seems kind of weird to represent an angle by a ratio of side lengths, but if that triangle is created from other similar triangles, they're all going to be the same number. Okay, and that's pretty important when it comes to that. So when people say, well, what's the significance of 4/5? You're never going to see that again. Yeah, you will. Maybe not for that triangle, for a similar triangle for it. Okay, let's go ahead and do an official example with it. Evaluate the 6 trig functions for the smaller acute angle. Okay, there we go. That's all they give me. Which, we still need stuff, right? I mean, there's still a hypotenuse missing. And we have to figure out what angle we're looking at, right? They want the acute angle. Well, we got two options, either angle A or angle B. So, if you remember, just basic geometry stuff, the sides that we're looking at here, 2 is the smallest, right? Okay? So the angle that's across from it has to be the smaller angle. So we're looking at angle B. So this is where I'm going to be basing all my trig functions from. Okay? So we're going to use angle B to do this. Does that make sense why we chose that? Pretty simple. Now I need the hypotenuse. So I can use what? Pythagorean theorem? Figure out the hypotenuse length. So I'll put that as x. So x squared equals 2 squared plus 9 squared. By the way, it's okay if they don't come out to be nice numbers. This one won't. Okay? So we get x squared equals, that's 4, okay? And then we get 81, so that's 85. And we'll take the square root, and we get square root of 85. We are dealing with triangles, so am I gonna do plus or minus there? No, right, I'm gonna keep it as the square root of 85. Okay, let's go ahead. It sometimes helps to label your sides. So this is my angle I'm looking at. So across from it, this must be my opposite side. 9 must be the adjacent, and then of course the square root of 85 is my hypotenuse. So there we go. We'll just go ahead and mark those. All right. Doesn't matter where you start. It really doesn't. I'm going to go in the same order that I did on that whiteboard there. So I'll start with sine. So sine of angle B. And if we look at what two sides go with it, it's your opposite and hypotenuse. So that's going to be the 2 over the square root of 85. Something else you covered in geometry. We can't have a square root in the bottom of a fraction. So because of that, I got to rationalize. Okay? So again, this is the answer, but I got to clean it up a little bit. So we're going to multiply top and bottom by square root of 85. Okay? So there's a little extra step if you have a square root at the bottom. So we have 2 square roots of 85. On the bottom, it's just 85. If you could reduce, reduce. We can't. We're done with it. So this is finished. Cosine of B. Let's see. So if I look on this board, that's the adjacent hypotenuse side. So there's B. So adjacent's the 9. Hypotenuse is square root of 85. And again, I have to rationalize it. I want to keep the square root at the bottom. You could probably, like some mental math stuff, you could see what the pattern's going to be. I'm going to multiply by top and bottom by square root of 85. So at the bottom, it's going to be 85 no matter what, right? The top is just this times the square root of 85. But if you need to see it, you can write it out. But I think some of you are going to start skipping some steps with this and know what the answer is going to look like without having to write that step. And that's perfectly fine. All right, let's keep it going. Tangent of angle B, so that's opposite and adjacent, so that's 2 over 9. I didn't have to rationalize because there was no square root to be done. next, we'll try cosecant of b. Okay, over here, I can see that's going to be the hypotenuse divided by the opposite side. So that's square root of 85. Over the opposite is what? 2 for that guy. Next, we'll do secant of b. Let's see. So secant is the hypotenuse over the adjacent side. So square root of 85 again, over 9. And the last step, we have cotangent of b that's adjacent over your opposite side. So that's going to be 9 over 2. Here's typically what I do. When they want all 6, I always go with sine, cosine, tangent. I go in that order. And then the next thing I do, we know that this is the same as this but flipped, right? So I just take this and flip it. I mean, you could look at the triangle and figure it out, but that's all you're doing. Secant, next one in line is just this flipped, so it's flipped. And then this guy is the same as tangent, but just flipped. So if you go in this order, you can find the other 3 quickly just by flipping. Okay? All right. Any questions? Make sense? Awesome. All right. Let's try this. Well, no matter what, I have to erase this. One way or the next. That's okay.
You need more whiteboard.
I do. Suppose tangent of theta equals square root of 3. Evaluate cosine theta. All right. Well, I don't give you a triangle. That's a bummer. But if they don't give me one, why don't we draw one, right? It makes it a lot easier to organize some information. But we're going to work a little bit backwards. We're going to see if we can't use one trig ratio to find another one. Let me go ahead and just draw a nice little triangle off to the side. Just put theta in that corner. No reason why. I just figured, we'll just put it there. I could put it up here. Now, this square root of 3, I could put it over 1, because that's the same thing as the square root of 3. And then tangent is your what? Your opposite side over your adjacent side, right? So let's use that information to fill out this triangle. So over here is opposite, this is adjacent, this is the hypotenuse. And I know this guy is opposite over adjacent. So this must be square root of 3, and this must be a 1. So we just pause for a moment. Any questions on how I did that with the triangle? Again, I'm just using what tangent is equal to. It's the opposite side over the adjacent side, okay? Now I need the hypotenuse because cosine, if you remember, uses the hypotenuse. Oops. So I'm going to use a little bit of Pythagorean theorem. So I'll let that be x. So x squared equals 1 squared plus square root of 3 squared. So we get x squared. 1 plus, that's just going to be a 3. Hey, this works out nicely, huh? So we get 4, and then we take the square, I get a 2. Now usually it's what, plus or minus 2, but we're dealing with a triangle, so just normal 2. So we're just going to do positive 2. Okay. So now, cosine of theta, we know is the adjacent side over the hypotenuse, right? I have all my information. Sorry, I guess I forgot to put 2 up here. Make it official. So that's going to be what? 1 over 2, right? It's going to be a half. There we go. Any questions on that? So even if they give you one trig function, if you draw your triangle, label it, find any side you need, you can find any of the other ones that you want to use. Okay. Now, let's talk about defining this using special angles. Now, what do I mean by special angles? I mean like 45, 30 degrees, 60 degrees. Those are very important type of angle measurements. So in other words, what I'm going to do is I'm going to stick in this quadrant. I'm going to pick 30, 60, and 45 degree angles and figure out what is cosine, sine, tangent, what are they all equal to? Okay? And we're going to use triangles to do that. So first off, let's create a 45, 45, 90 degree triangle. Okay? Because a 45, 45, 90 has the special angles we want. If you remember, I don't know, I keep saying if you remember from geometry, I really don't know if you do or not. But let's just take a nice little square, which has 90 degree angles. Okay? I'm going to cut it in half with its diagonal. And just for the sake of things, let's call this diagonal just like 1. Okay? This has a length of 1. Because I'm cutting these 90s in half, they become 45 degree angles. Okay? Now I don't know what the side lengths of the square are, so I can use x. All right, so I'll put x and x here. And so this is me creating the 45, 45, 90. Let me just draw it outside of here. That way it's a little bit cleaner. So there's 1, here's x, and there's x. So what I'm going to do is I'm going to find the sides for x and x, and then we're going to find the trig functions for it. Okay? So we have here x squared plus x squared equals 1 squared. We're going to just use Pythagorean theorem to do this. So this will be 2x squared equals 1. I'll divide by 2. And then we'll take the square root. Now again, we're dealing with a triangle, so I'm going to keep the positive root. So we have plus, I don't have to write plus though. So it's going to be square root 1 over 2, which is 1 over square root of 2. Just like this problem, I want to rationalize it. Okay, I don't want to leave it like that. So I'm going to multiply top and bottom by square root of 2 over 2. And we get square root of 2 over 2. That's my final answer. So these two sides, where's my red marker here? So this is going to be square root of 2 over 2, and so would this be. Okay? So there we go. There's my 45, 45, 90, and those are the side lengths that correspond with it. Now the good news is, if I were to make a different 45, 45, 90, it's going to have these ratio lengths, which is really cool. Okay, so these numbers are always going to appear no matter what the side lengths are. Okay, let's go ahead and talk about these angle measurements. Let's pick, it doesn't matter which we pick, because no matter what, it's what's square root of 2 over 2. So let's do cosine of 45 degrees. And like I said, it doesn't matter. Let's just say I picked that part. So this is my opposite, this is my adjacent, this is my hypotenuse. Just to pick an angle, but again, you're going to get the same answer no matter what. So cosine is going to be adjacent over hypotenuse. So that's going to be square root of 2 over 2 over 1, which is just square root of 2 over 2. Okay. So at any point, you see cosine of 45 degrees, the two ratios, or the two side lengths that go with it as one ratio is square root of 2 over 2. Here's the cool part. If you type that in your calculator, it'll spit out square root of 2 over 2 as a decimal, but it'll actually spit that out. Okay, next. Sine of 45 degrees. Okay. Does it really matter? Am I going to get the same answer? I think I am, right? Okay, it's your opposite over hypotenuse, which is still square root of 2 over 2 over 1, which is just square root of 2 over 2. So it didn't change. So sine and cosine of 45 degrees, both equal to that ratio. All right, let's look at tangent. So opposite, well, let me write the ratio down part. Opposite over adjacent, square root of 2 over 2 divided by square root of 2 over 2. And what's that be? 1. 1. Okay. So I'm going to pause for a moment. Any questions on how we found those values? Now, do you have to derive the formula? No. I did that so you could see where these come from. I could have just started here and just said, here's a right triangle, 45, 45, 9. These are the ratios and go from there, but I wanted to show you where it came from, that's all. Alrighty. Let's do a 30, 60, 90 triangle. So we're gonna do that next. And then we're gonna summarize all this in one nice little neat table, okay? And we'll go back to this one. Well, yeah, we'll stick here. Stick it right over here. Okay. So now, let's create a 30, 60, 90 triangle. So we're going to repeat the same process. I'm going to figure out what the ratio of the side lengths look like and then define these trig terms. So let's say you start off with a equilateral triangle, which we know equilateral is the same thing as equiangular. Using some theorems from geometry. Okay. Now to make this 30, 60, 90 triangle, I'm going to draw an altitude. Okay, cuts that in half. So then this is 90. This is now 30. Okay. Now because it's equilateral, or equiangular, mean the same thing, aren't all the sides the same length, right? So let's just call the side lengths x, x, x. And because I drew this altitude, it cuts this in half. So this is going to be half of x. Okay. And let's call the altitude h for height. Makes sense. Now let's figure out what h is and what x is, and then we have our ratios for our 30, 60, 90. So let me draw it over here a little bit cleaner. That's just me creating it. So this was 30, this was 60, this is half an x, this is h, and this is x. Okay, so what we're going to do is we're going to find h. Now, if you look at the x's, they could be any number whatsoever. I could have made all these side lengths 3s. Okay, I could have made them all 6s, doesn't matter. But one of the things I want you to look at is, whatever this measurement is, this is going to be half of it, right? That's one of the special things of this triangle. So let's figure out what h is. So using a little bit of Pythagorean theorem. So x squared equals h squared plus half x squared. We get x squared equals h squared plus 1/4 x squared. Now, because these are both common terms, I can subtract this over to the other side. So this would be 1 minus a fourth. Okay, so we're going to get 3/4 x squared equals h squared. And then we'll just take the square root to both sides to finish. So we'll have square root of 3 over 2. This will just be an x now, because x squared is being square rooted, equals h. Where's my red marker? There it is. Okay. So this guy is going to be square root of 3 over 2x. So again, x is whatever the side lengths were initially. So it's always going to follow that ratio, that pattern. Okay? Let's go ahead and use, I'm going to box this out so we can see it better. Let's go ahead and find cosine of 60 degrees. We'll do sine of 60 degrees, and we'll do tangent of 60 degrees. All right, now we're going to find those trig lengths. And again, the x's could be any number. It's just it's always going to be a ratio of 1 to half to the square root of 3 over 2. Because you're going to see the x's are going to cancel out. So cosine of 60. So here's 60. This will be my adjacent, my opposite, my hypotenuse. So this is going to be the adjacent side over hypotenuse. So that's going to be a half x over x. Boy, I did not space this out well. I'll put it up here. So that's going to equal a half. The x's will cancel out. So anytime you have a cosine of 60 degrees, it's always going to equal a half. Okay, sine of 60. So here's 60. So opposite hypotenuse. Opposite hypotenuse. So that's going to be square root of 3 over 2. Okay, divided by, oh, sorry, there's an x there. X over there. We can see that the x's are going to cancel. So we get square root of 3 over 2. So sine of 60 degrees is equal to square root of 3 over 2. Every time. And tangent. Let me write this down here. They're all blending into each other here. So that's your opposite with your adjacent side. So let's see, opposite side was square root of 3 over 2 x. Your adjacent side was a half x. Now I know the x's are going to cancel. And if I divide by a half, it's like multiplying by 2. I'll put it up here. So that's going to be square root of 3 over 2 times 2 over 1, which is just square root of 3. So tangent of 60 degrees is square root of 3. Again, your calculator knows this, but it's not going to give you the fraction, it's going to give you the decimal version of it. Okay. All right, we still have 30 degrees to go. I want to put on the same board. I think we're okay if I erase this part, right? I think are we okay if I erase the little mark over here? Okay, people shaking hands. All right. Again, I just want to kind of keep on the same board. So cosine of 30 degrees. Let's do that next. So that's going to flip my ratios here. So I'm looking at this spot. So this is now my opposite side. This is now my adjacent side. That's my hypotenuse. So let's see, cosine of 30. So it's going to be square root of 3 over 2x. What's that? Oh, over x. There we go. And the x's cancel. I'll just put it off to the side. So it'll be square root of 3 over 2. So cosine of, I'm marking myself. Cosine of 30 degrees is square root of 3 over 2. All right, next, sine of 30 degrees. Okay, so that's going to be the half x over hypotenuse, which is x. So we know that the x's cancel out. So sine of 30 is always equal to a half. Last one, tangent. So this is going to be a little bit more work. So it's going to be a half over square root of 3 over 2. Let's do some side work over here. That's the same thing as a half times 2 over square root of 3. Running out of space. So we can see that these 2's are gone. They're going to reduce. So we get 1 over square root of 3. And again, we want to rationalize that. We don't want to leave it like that. So I'm going to multiply top and bottom by square root of 3. I just have enough space. So square root of 3 over 3 is tangent of 30. And those will never change. So no matter what 45, 45, 90 is drawn, no matter what 30, 60, 90, whatever these side lengths become, whatever they are, okay, they're always going to match up to this. Always. Alrighty, so that's special angles. Now, just to let you know, if I want to find the other 3, right, cotangent, cosecant, secant, I would just take these guys and flip them, right? That's all you would have to do to find those ones. The reason why I'm not listing them here is because you're going to see this a lot more often than the other 3, okay? And if you need the other 3, again, you can use those and just flip the values over and you're good to go. So let me go ahead. I'm going to draw a table here with all this information. And then we're going to use it and pretty much wrap things up. All right, so let's summarize. So in summary, this is what we got. What I'm going to do, because they're not like too scattered, but I want to put it in one little table so you guys can have in your notes so it's easy to reference from. Next to each angle measurement, I'm going to put the radian measure. Okay, so converting these to radians, this is the same thing as pi over 6, same thing as pi over 4, and same thing as pi over 3. Okay, so there we go. Now let me go ahead. I'm going to write down all the values. I'm going to do it all at once, and then I'll step back so you guys can write these down yourself. So one moment. guys go ahead and write those values down. I'm going to put, so right here, I'm going to put a big star. Okay, those values, okay, this next like week and so, I need you to memorize those ones, okay? You have to know those. If you don't know them, can you derive it? Yes, but it takes more work. So knowing those off the top of your head is very critical, okay? Now, the reason why I didn't mention these guys over here is because, like, again, I could find all these numbers by just taking the reciprocal of all those guys. But those 9 right there, throughout the whole entire year, you're going to need to know those. Seems like a lot, but we're going to be working with them a lot in this class, okay? So it'll become second nature to you. And if you end up taking calculus after this, you're just going to keep using them, okay? So if they ask you what sine of 45 degrees, you know it's square root 2 over 2. Like, immediately you know that. Okay? So the ones I have out here starred, it's a must. You have to know those. And again, don't be overwhelmed by it. You're going to have time to practice and get to know them. Okay, now that we know this stuff, we can start simplifying some expressions with trig values in them, which is really cool. So let's try this example. So we're going to simplify the expression. Now, can you type stuff like this in a calculator and get an answer? Yeah, absolutely. You can. But all the time, you're going to have a calculator, and actually, sometimes the calculator, again, the calculator is going to be a decimal version of the answer, which might not be as useful as the fractional component. So let's look at part A, and what I'm going to do is just substitute the values from this table, okay? So let's go ahead and do that. So cosecant, I'm going to write this off to the side. So cosecant of 30 degrees, if I look at my table, so here's 30, okay? And cosecant here is 2. Sine of 30, okay? If I look at my table, we can see that's a half. Now again, I told you to memorize that first section. So if I know sine of 30 is a half, and these are kind of related to each other, I'm just flipping it, okay? So then we just get what? If I go throughout this whole thing, this is equal to 2 minus a half, which is just 1 1/2 or 3 over 2. There we go. That's awesome. That's something that's really incredible that you can do that without touching a calculator. Okay, over here is radian measure, but that's okay. Let's see, so cosine of pi over 6. Okay, so let's go over here. So here's pi over 6. Cosine is square root of 3 over 2. So let's go ahead and put that there. Okay, next we're going to do sine of pi over 6. So it's going to be a half. Okay, and then we got one more to go, right? Cosine of pi over 3. So we'll go over to our table. So pi over 3, that's 60, and cosine's a half. Okay. Now again, I'm just writing these down. Could you just do a direct substitution? Absolutely. I'm just trying to make it easier in your notes to read. So let's plug those values in. So we get square root of 3 over 2 times a half plus a half. So this is going to be square root of 3 over 4 And then, finding common denominators. This would be what? 4 over 2? Nope, not 4 over 2. Oops. 2 over 4, I meant to say. Which becomes 2 square roots of, well, oh man. Brain needs to work. 2 plus square root of 3 over 4. So there's my final answer for that guy. Okay. All right. Any questions? It's a lot of info, right? A lot of things thrown at you. But again, we're going to be practicing this throughout the week. Okay? Now, one thing to cement, looking at this table, and I kind of mentioned at the beginning, that sine, cosine, tangent, and the other 3 functions, they're related by just being reciprocals of each other. Okay? So for instance, I could see that if I flip this, I get cosecant, right? It's just the reciprocal of this guy. If I flip this guy and rationalize it, it's the same as secant. If I flip this and rationalize it, I get cotangent. Okay? So they're reciprocals of each other. So let's talk about, oops, it's gone. Reciprocal identities. Okay. And we'll put this over here. Okay, so let me, might as well just finish it. Get my marker cap. Okay. So, if I know that these 2 are reciprocals of each other, cosecant of theta is the same thing as 1 over sine of theta. Okay. So instead of memorizing that that's hypotenuse over opposite, you can just memorize the fact that they're just 1 over this. Okay. Secant, that's going to be 1 over cosine of theta. Okay, they're reciprocals of each other. And again, we can use the table to see that fact. Okay, cotangent is the same thing as the reciprocal of 1 over tangent. Okay. Now we could, and again, there's so many different things being thrown at you right now. I would just, right here, those are good. Knowing those ones there is very important. But also note this, if I take the reciprocal of this, I get sine again. So over here, I'll just put and it's an obvious property, but still, just to kind of put things in perspective. If I take the reciprocal of this guy, I get sine of theta again. It's like 1 over sine of theta. Over here, if I take the reciprocal of secant of theta, I get back to cosine. And if I take 1 over cotangent of theta, I get back to tangent. Okay? But again, you're going to be using this part a lot more. Okay. Now, there's 2 other identities that are pretty important, and you guys are going to mess with it for homework tonight, like where it comes from. But tangent of theta can be rewritten as sine of theta over cosine of theta. And cotangent can be written as cosine of theta over sine of theta. Okay? Those are 2 other ones that we're going to be using a lot of. And again, for homework, I want you guys to figure out why is that the case. And what I would do is draw a triangle and substitute some things together to see that that works. Okay? It's just a little suggestion for it. Alrighty, last example. Man, I hate erasing that. Oh well, we're erasing it. It's gone. Okay, here we go. Given that sine of phi is equal to 7 over 9, and cosine of phi is square root of 65 over 9, use reciprocal and quotient identities to find the other values of the other, that doesn't sound right in my head, trig functions of phi. Okay, there we go. So sine of phi is 7 over 9, cosine of phi is square root of 65 over 9. Use the reciprocal identities to find the other ones. Now, here's the deal. I could draw a triangle like I did at the very beginning, label the sides, and find everything else. But now that I know that this stuff is true, I can use that information to find those values faster, okay? There's always more than one way to do trig, which is nice. So here we go. I'm just gonna, okay, so those are the other ones we need to find. Those are the other 4? Yeah, the other 4. And again, I'm just going to use those reciprocal identities, okay, to figure out those other values. Yep. Okay. So for the first one, if I look over here, I know tangent of phi is the same thing as sine of phi over cosine of phi. So I'm going to go ahead and plug those numbers right into here. So it's going to be 7 over 9 over square root of 65 over 9. So flipping it over and multiplying, I get 7 over square root of 65 when I simplify it. I do have to rationalize, so we'll multiply top and bottom. And we get 7 square root of 65 over 65. Okay. Now again, knowing that identity, I got to that quicker than me drawing that triangle, labeling the sides based on the information. Okay, cotangent is cosine of phi over sine of phi. Okay. So let's go ahead and plug those in. So square root of 65 over 9 divided by 7 over 9. I knew I wrote those way too close together. Had a feeling. Okay, so that's going to simplify to square root of 65 over 7. 9s are going to reduce out. Next, cosecant of phi. Same thing as 1 over sine. Wrong color. Don't want to do that. Can't destroy the flow of this. So let's see. Sine was 7 over 9. So this is 1 over 7 over 9, which just flips it. So 9 over 7. And last one, secant of phi is going to be 1 over cosine of phi. And let's see, that's this guy over here. So 1 over square root of 65 divided by 9. Okay, so that's going to be 9 over square root of 65. We're going to have to rationalize it because we don't want to have that in the denominator. And we get 9 square root of 65 over 65. There we go. There's the end of part 1. Okay. By the way, this lesson actually continues, but I feel like this is enough information because right now I just want us to get into what sine code, what all 6 are. I want you to be able to do those, okay, and to evaluate off of a triangle and so forth before I teach you anything else. So I think this is enough to kind of end things. Any final questions? Awesome.